Hello, this is Tom from TutorBros. Today we are going to learn how to solve a system of linear equations using the substitution method. So we'll take a look at our first example here, y equals x plus 4 and 3x plus 2y equals 13. So what do we do to solve this system? Well, you'll notice in the first equation that the variable y is isolated, so it is by itself, and it is equal to the expression x plus 4. So if it's equal to the expression, then we can say that it is interchangeable with that expression. What we can do with that information then is we can rewrite the second equation here, and wherever we see the variable y, we can swap it out with the expression x plus 4 because they are equal to each other. So let's do that. We will write down here 3x plus 2y, but then again, y is equal to x plus 4, so we'll replace the y with x plus 4 equals 13. And we'll do some simplifying here. And again, the point of this is so that we can rewrite one of the equations using only one variable, so that we can solve for that variable and then go back and solve for the second. So we will do our simplifying here. In this part, I'm just distributing the 2. And then we'll combine our like terms with 5x plus 8 equals 13. We'll subtract 8 on both sides, 5x equals 5. And then we divide both sides by 5 and get x equals 1. Okay, good job, Tom. Now we go back, we can take either of the two original equations, doesn't matter which. We can plug one in for x, and then we can solve for y. I'm going to take the first equation, it's probably easier to work with, so I'll copy it down here. Y equals x plus 4. And then again, we know that x is already equal to 1, so y equals 1 plus 4. And of course, then y is equal to 5. So the solution to this system of equations is x equals 1 and y equals 5. Okay. Let's try another example. Now we'll do x plus y equals 2 and 2x plus 5y equals negative 2. Alrighty. Now this one's a little bit different because neither of the two equations is isolated for one of the variables. But you'll notice that in the first equation, we can manipulate the equation just a little bit and very easily isolate for either x or y. Doesn't matter which, I'm going to choose y just because I want to. So how do we do that? The only thing we have to do really is subtract x on both sides of the equation in this first equation here. So I'll rewrite it down here after I've subtracted x on both sides. So y is equal to 2 minus x. So again, just rewrote this equation after having subtracted x on both sides. Okay, now this equation has been isolated for y, and then we can take the second equation and plug the expression 2 minus x in wherever we see y. So I'll write that down here. So 2x plus 5y, and then again we're substituting 2 minus x for y. So I'll write 5 times 2 minus x equals negative 2. And then we'll do our simplifying again. Distribute the 5. 10 minus 5x equals negative 2. Combine like terms. Negative 3x plus 10 equals negative 2. Subtract 10 on both sides. Negative 3x equals negative 12. And then divide by negative 3 on both sides. X equals 4. Perfect. So we found the value of x. We'll go back, take one of the two original equations, and we'll solve for y. And I will write the first equation. I'll rewrite it over here. X plus y is equal to 2. And then we know that x is equal to 4, so we can say that 4 plus y is equal to 2. And then we just subtract 4 on both sides to solve for y. So y is equal to negative 2. So now the solution to this system is x equals 4 and y equals negative 2. Okay, we are doing a great job. One more example. Alrighty, 10x plus 10y equals 10, and 5x minus 3y equals 1. Now you may be wondering if using the substitution method here is the best way to go, because with this system of equations, it doesn't look like we can easily isolate for either x or y in either of the two equations. But if you look closer at equation 1, you'll see that each of the terms in the equation is divisible by 10. So why don't we divide both sides of the equation by 10? When we do that, you will see that 10x plus 10y equals 10 becomes x plus y equals 1. So again, all we did was divided both sides of the equation by 10. And now we have an equation that we can easily manipulate in order to isolate for either x or y. I'm feeling funky now. I'm going to isolate for x. So I just subtract y on both sides, and then I get x equals 1 minus y. Then I'll go back, I'll take the second equation, 5x minus 3y equals 1, and then I will rewrite it and substitute 1 minus y wherever I see x. So let's do that down here. So we have 5 times x, which again is 1 minus y, minus 3y equals 1. We will simplify by distributing the 5. That's 3y equals 1. Combine our like terms, so that would be 5 minus 8y equals 1. Subtract 5 on both sides, so we'll get negative 8y equals negative 4. And then last step, I'll write it over here. We divide both sides by negative 8, so then y is equal to positive 1/2. Okay, then we can go back. We can take either of the two original equations from the system of equations, or we could even use this equation here, because again, this is the same as this equation up here. All we did was just divide both sides by 10. So I think I'm going to use this one down here, x plus y equals 1. I'll just rewrite it over here for the sake of clarity. And then we will substitute 1/2 for y. So I'll write that down here. X plus 1/2 equals 1. And then to solve for x, we just subtract 1/2 on both sides. So x, as it turns out, is also equal to 1/2. So the solution to this system would be x equals 1/2 and y equals 1/2.